Hello again from CodeWord. This is Samvid Mistry and let's try to finish this calculator in this video. I try not to make videos longer than 12 to 15 minutes, so let's just see what we can do. We left the last video after scanning the input properly into the string, but we cannot perform mathematical operations on a string. We need an integer. So let's just create an integer from string choice. We have the choice variable now. Let choice equals choice dot trim dot parse dot expect. God, I hate my neighbors. Please enter an integer number. Okay, so I can already hear some people screaming that I cannot have two variables with same name in a single scope, but Rust has a feature of shadowing, which essentially means that whenever we define a new variable with the same name as the previous variable, the value of previous variable just get replaced with the new variable. Now, looking at the statement, we can see that we didn't give any type information about what type of variable we want after parsing the string. Parse method can parse all kinds of numbers, but we need to tell Rust about what type we want our variable to be. Otherwise it will become ambiguous, and ambiguity is something we are definitely trying to avoid. So let's just say we want integer of 32 bits. There are other types in the system, as you might have guessed, and they are all available on the site, but as we progress towards the end of the series, we will explore most of the useful types for you, so don't worry about that. Most of the times we won't need to specify the type manually because Rust has a really strong type inference system, and this is one exception that we need to make in order to make the program clear. So now we have converted the value. Let's check if the value we are getting is the right one. We'll print it. That's the good old style of debugging. The user's choice is, now what do we type here? If we type choice, it will just take it as a literal string and print choice, which definitely we don't want. So we need some kind of placeholder value which we can put in the string, which will then be replaced by the program at runtime and print the value specified instead. In Rust, the placeholder to specify a value is the open close curly brace. It is quite similar to what we have as %d in C language. Now of course we need to specify what value to replace in the placeholder, so we'll specify choice here. Let's just check if the program works. Cargo run. Okay, slow this time. Okay, we're here. 10. User's choice is 10. Perfect. Now if we have multiple arguments here, then the order of arguments does matter, because then the arguments will be replaced in the string in their respective order. Now the code seems to work fine, so we'll just copy paste the code to scan two inputs for our operands. Now you should keep that in mind, that it is not good to copy paste the code without actually knowing what's going on. If you know what you're doing, then by all means go ahead and copy the code. So we'll name it first as the first operand. We place it here, and then here first, and then here. Same for the second one. Second. People actually make a job or a living out of copying pasting code, so I think it's alright. We now have our operands and we know what operation user wants. So there are two ways we can approach further. First is we can use an else if ladder, which is just a bunch of if statements glued together, or we can use a match expression, which is Rust's version of switch, and it is more like a superpowered switch statement. We will see both ways, and then you can decide for yourself which one of the solutions is more elegant for you. The structure of if statement is quite simple, as we can see here. If followed by a condition and then a block of code which gets executed if the condition is true. We can optionally attach it with an else clause, where else is followed by another block of statements which gets executed whenever the condition is false. Now what you can do is within the else block we can just put an if block which gets nested and however much deep you want. And this is so common in programming that we have given it a special syntax, else if, and here it goes. So this is the way we're going to implement our choice mechanism. We need another variable to hold the result of our operation, so let result, and we're going to specify the type explicitly here because there is no right hand side to infer the variable type from, and we'll just specify a bunch of if statements for every kind of choice we have. So if choice is 1, then we'll just go ahead and add the two operands. So result is first plus second. Else if, you might have guessed it by now, choice double equals 2, then result equals first minus second. We're just applying basic operators here. Else if choice is 3, then result is first multiplication operator second. Else if choice is 4, then result is first divided by second. Finally, if the user has entered anything except these 4 choices, then we'll say this is an error. Println, please enter a number from the menu, and we need to give result a value, otherwise the program won't compile. That is because if the flow of program goes to else block and then tries to use the variable later in the program, then it may not have any value assigned, and accessing an uninitialized variable might lead to unexpected behaviors and potential bugs. The final thing to do now is to print the result. We will again use a placeholder for that. So println the result is a placeholder and result. I'll stop reminding you about the placeholder now because I think I've said it enough times for you to grasp. And I think we're done with our simple calculator. The one final thing to do is to check if it actually works. Cargo run. Let's see, we want to add 2 numbers, 10 and 20. The result is 30. Definitely perfect. Let's see, let's run. 2 subtract 20 from 20, 10 from 20. The result is 10. Perfect. Now it lacks a bit of user experience problem. Let's see, we're asking for choice and then we are not asking for operands, so user cannot know what he's supposed to do. So enter first operand and then enter second operand. Let's check. Much better. Now the user knows what he or she is supposed to do, and the result is 30. The remaining cases are multiplication. 10 multiplied by 10 is 100. Then division. 100 divided by 5 should be 20. Yes, the result is 20. And let's try something out of the blue. 100, 20, 30. Please enter a number from the menu. The result is 0. I know it is kind of the flow of the program is kind of funky, and I should not ask for the operands if the choice is not of the menu, but this is a basic video and we're just getting started here, so I think it's alright. And in other cases it just works fine. So let us also see the powerful match expression which can help us tackle the scenario with much less and readable code. Let's just first get rid of all this ifs and elses. Now, as I said, match is an expression, so it can be used in the right hand side of the variable. Let's go. We can get rid of the type because we are providing the right hand side. Now match is similar to switch. So match then followed by your choice, which is conveniently named the variable choice. Then bunch of cases. What if the choice meets equals 1? Then we can add the two operands. First add second, then moving on the similar pattern, if 2 then first multiplication operator second, then if 3 first, made a mistake, subtract, multiply, what's this, second, if 4 first, divide second, and finally if nothing matches, then this is the underscore. Underscore is actually called catch-all operator. It catches all the values except the specified above, and we're going to need multiple statements here, so we need to specify a block. The block actually returns the value of the final statement in the block. So we'll first print, please enter a valid choice, and then return 0. Notice we cannot specify or type a semicolon at the end because that will make it a statement and not an expression. And that's it. Much readable code. Oh, forgot the semicolon. That's it. Much readable code, much natural, and actually quite less verbose. Let's check if the calculator still works. Cargo run 1, 10, and 20. The result is 30. Perfect. We are quite done with our calculator, but there are still some cases where it needs polishing in order to make our calculator work seamlessly instead of running the program again and again and again. You might have guessed that we are going to talk about loops in the next video, so I'll see you then. If you liked the video, please hit the thumbs up button, subscribe to my channel, and share this video to all of your friends. Peace.